guys, welcome again to the Genius Media YouTube channel, and I'm your humble host, Humble Genius. All right, welcome back. So on the board, we have question 1b. Now this question says the velocity v of a transverse wave along a stretched wire varies with the tension, mass, and length. According to the equation, v is directly proportional to t raised power s, m raised power y, l raised power z. Deduce the formula for v by method of dimensions. Now, let me write the relation we were given. So we were given solution. We are given relation of v directly proportional to t raised power x, m raised power y, and l raised power z. And we are asked to deduce the right formula. And before we can deduce this right formula, we need to know what is x, what is y, and what is z. So once we know the value of x, y, and z, and we substitute it into this formula or this relation, okay, then we can be able to know the formula for v by method of dimensions. And this method of dimensions involves, for us to solve this, we have to slot in the dimension of v, the dimension of t, the dimension of m, the dimension of l. After slotting in the dimension, then we would follow a principle. We'll apply a principle called the principle of dimensional homogeneity. And that principle of dimensional homogeneity just simply states that any dimension on the right hand side must be equal to dimensions of quantities on the what? Right hand side. Once we state that, then we will now compare both sides to make sure that what is on this side must be equal to what is on this side. After that, that will help us to develop equations that will help us compare the powers of right hand side and the powers of left hand side, which will help us get what? X, y, and z. Join me, let's solve this. Okay, so I was told that v stands for velocity. So before I would insert this dimension of t, dimension of mass, dimension of length, and dimension of velocity, I have to remove this. This is proportionality sign, so I have to introduce an equality sign. So that will become v equal to, so when I introduce an equality sign, a constant comes in play. T raised power x, m raised power y, and l raised power z. Okay, so at this junction now, we have to do something. What we have to do right now is we have to introduce dimensions of every quantities on the right hand side and on the left hand side. But then k is the dimensionless constant, so we say it should be equal to 1. So now let's continue. Continuing on this board, so I have my v. Dimension of v is actually lt raised to power minus 1. Now let me state the dimension of all the quantities. Dimension of t. What is t? According to what we have, we were told that t stands for tension. So tension means force. All right. So dimension of tension is also going to be the dimension of force. Tension is the same thing as force. So that will be equal to what? M lt raised to power minus 2. Okay. Now I have to also state what's the dimension for L. L is, what does L? L is length. Dimension for length is L, right? So we've stated dimension for velocity. What's dimension for mass? Dimension for mass is capital M. All right. So let's substitute all. So for substitute everything into this equation, m raised to power y, c raised to power x, then l raised to power z. So substituting the dimensions, I have for velocity to be equal to lt raised to power minus 1 equals to m raised to power y. This tension, that's m lt raised to power minus 2 all raised to power x, right? Then I have my l raised to power z. Now I have to simplify what is on the right hand, on the left. This is on my right hand, so I have to simplify what is on the right hand side. Hope you understand what I'm doing. So at this stage, what I need to do next now is simplify. So I will open this. So I have m raised to power y. So this becomes m raised to power x, l raised to power x. I'm using this power to multiply all the powers. Then t raised to power minus 2x. Then l raised to power z. Now you will notice that I have l. So I will take one l, and then since this is multiplication, I would add the powers. That's indices law. Okay, so let's go. So that's giving me. Also, I have 2m, so I'll take 1m and add the powers because this is multiplication. So I have y plus x times l raised to power what? X plus z. Simple. And then my t raised to power minus 2x remains. Now, n is on this right hand side, okay? But there's no m on this right hand side. So how are we going to compare to make sure what is on this side is equal to what is on this side? Now, for us to do that, we are applying principle of dimensional homogeneity. Now, what does this principle of dimensional homogeneity say? It says that the dimension on the right hand side, so dimensions on the left hand side, will be equal to dimensions of quantities on the what? Right hand side. So we have to introduce m on this side. Abi, there should be an m on this side that should be equal to this m here. So look at what I'm going to do. So how are we going to introduce that? What do you think we are going to do? Since naturally there was no m on this side, so I'll introduce m raised power 0 because any raised power 0 is t1. So it doesn't affect our lt raised power minus 1. Hope you got that. Now let's continue. So I have m raised power y plus x times l raised power what? X plus z times t raised power what? Minus 2x. Now, as this junction, we will now do what we call equating. So I can say, because everything on the right hand side must be equal to what's on the left hand side, so I can say m raised power 0 is equal to what? M raised power what? Y plus x. Right? So what I have here now, I will say equating powers. Equating powers. So I have 0 equals to what? Y plus x. So this is equation 1. Easy. So in the same vein, we will come over here. Hope you've taken down this question. So let's continue. In the same vein, we'll come over here and say L is equals to L on the right hand side, which is L raised by x plus z, right? Yes. So this is 1 because the power of L here is 1 is equal to x plus z, equating of powers. Okay. So this is our equation 2. Of course. Now we can still also say that t raised by minus 1 is equal to what? T raised by what? Minus 2x, right? And that will give me equation of these powers now. This power must be equal to this power. Minus 1 is equal to what? Minus 2x. So this will give us what? Equation 3. Now we'll form 3 linear equations. So from these equations now we'll find x, y, and z. And once we find it, we'll plug it into the original relation, right? This relation, and then that will give us the original or the dimensionally correct formula for this relation. Okay? Alright, so let's go. From here, my x is equal to minus 1 divided by minus 2. Minus cancel minus, so we have 1 over 2. So if I have this, I can find z from here because substituting for x in equation 2. So I have x plus z equals to what? 1. So substituting for x, I have 1 over 2 plus 2 equals to 1. Right? Sorry, this is not 2. This is z. Z. So I'm looking for z. So taking this to the other side, I have z equals to 1 minus 1 over 2. This will give us what? Minus. Would it give us minus? No, 1 minus 1 over 2 is still what? 1 over 2. Okay, that's simple. So let's solve. Now, from equation 1, I have 0 equals to y plus x from equation 1. Of course, this is equation 1. Okay? This is equation 1. So I need to find my y from here. I know x. So y, of course, is supposed to be equal to minus x, right? So y is equals to minus, what's our x? Our x is 1 over 2, minus 1 over 2. Simple. So with what we have now, we'll have to substitute it into the original relation. So I'll come here, cleaning all this. I'll come here, substituting my x being equal to 1 over 2, my y being equals to minus 1 over 2, and my z equals to 1 over 2. Substituting all into this relation. So I have v equals to m raised power minus 1 over 2, t raised power 1 over 2, l raised power what? 1 over 2. So what we have here now, this is the same thing as saying 1 all over m raised power 1 over 2, right? Times t raised power what? 1 over 2, l raised power what? 1 over 2 over 1, right? And there's something I want you to understand. If these two multiplies each other, this is according to indices, I can bring them up. I have v. From here, I can have t raised power 1 over 2 times l raised power what? 1 over 2 all over m raised power what? 1 over 2. From here, we have common powers. So this can still be the same as t l over m all raised by what? 1 over 2. Making sense, right? Yes. Okay, so we have v equal to What do we have here? TL over m raised by 1 over 2. From there, we have square root TL over m. Remember your indices. 1 over 2. Remember your indices. A raised by 1 over 2 is the same thing as what? Square root a. So that's what I did here. Of course, because of this your equality sign, you introduce your what? Your k constant that we initially made to be equal to 1. So our equation, our final equation, our final answer should be v equals to k roots cl over m. Of course, that's the proportion. That this is proportionality constant. So if you like, you can, after stating this, you can say let k equals to 1. At the end of the day, you still have this equals to square root TL over m. So you can leave your answers in this form. So we've come to the end of the solution. Hope you understand this. Drop your questions in the comment section. Let's move to the next question.